Hello, everyone. Welcome to the IoT Blueprint webinar. We're very excited to have you on board today and look forward to sharing a lot of interesting information. To introduce myself, my name is Raheel Reddywala. I'm the Executive Vice President here at Productive Edge. I'm also a co-author of a book called Winning the Digital Gamble, primarily focused around the Industrial 4.0 and IIoT opportunity and sort of the operating model that companies need to consider as they get on the IoT journey. I've also been fortunate to have worked in IoT and real-time data space for the last 10 years across various industries. I've done a lot of work in telecom, in healthcare, in industrial manufacturing, bringing new products to market, either as a B2C or B2B2C type products, factory automation, in the food processing space, water, smart cities, building infrastructure. So we've got a lot of good perspective on what things looked like 10 years ago and on where things are today. So I'm looking forward to sharing all that insight with you in a very focused webinar. So our agenda today is us discussing. I'll first start off by discussing an IoT blueprint. That's based on our experience in delivering IoT projects and programs for various companies over the last 5 years or so. And then I will start creating a framework for defining various cloud platforms that have very good solutions out in the market today against that blueprint. And then we'll kind of look at recommendations on how to even begin the process. So the assumption here is that you're either just getting started in your journey of looking for the right IoT technology strategy and start building on that journey now, or you've just begun that and are looking to evaluate cloud platforms that will support your strategy. So hopefully this is of use for you, and let's get started. So just to set the stage, when we think from a Productive Edge perspective, smart services, we really think that connected products and connected specifically machines are enabling not just a different kind of a product, but really it's the services that surround the product that drive the big opportunity for your companies. And if you think about those opportunities, you can think of them in sort of low-hanging fruit perspective, like what can I just get going today? Why should I do it? Why should your business invest in actually building a connected machine? We all know that actually the engineering aspect of building a connected product is not easy, and there's a lot of cost to that. So why would a company go through that cost? What is the return? And what can you get in return? And that's what we're looking. That's what I'm trying to talk about. Is there are some low-hanging fruit opportunities that that are easy to understand and grab, but then there are some opportunities that are beyond the low-hanging fruit that most companies are not necessarily seeing that. And it's important from a technologist standpoint to understand where things may go so that you're able to take advantage of the right platforms, knowing that the future may look quite different than where you are today. One of the key aspects today are pretty straightforward, things that you would expect. You want to be able to provide new services, more predictive services, more tiered service offerings to your clients. You want to provide customer satisfaction, increase your customer satisfaction to give them more visibility around the asset utilization that you have. Be able to do more proactive maintenance, preventative maintenance. Send people out in the field to address issues before they arise. Things like that. And as you think about moving forward beyond that, there will be a bigger focus on revenue generation. What else can I do with this connected product and with the industry and where things are going from a technology enablement perspective? So there are various opportunities there that I'm sure your companies will explore once the low-hanging fruit is sort of grabbed. So things like data monetization, things like being able to even manage contracts dynamically and personalize the contract terms to a particular client, because you're able to deliver very, very focused service agreements that are bounded by a very personalized relationship and a contract, a contract that needs to be personalized for that particular client. platform-enabled marketplaces. Imagine your product actually extending its capabilities because others are building on top of that. We're seeing that across the board here. Connected ecosystem. So when you think about a smart building, me building a particular component within the smart building, then me and my product working with all the other components and machines in the smart building. Or think about a factory automation process. Those are examples where your product, your technology is part of a bigger ecosystem, and how will it play with the others, and how will it actually deliver added value and deliver differentiation for you and your company. Obviously there's field service optimization, making sure that the right people are available to address issues at the right time. There's SLA management, so you make sure that if you're bringing new products to market, new services, that you're delivering the right SLAs and things of that sort. And then over time, in the very long term, we see things where machines are able to talk to each other, autonomously do things, and you're optimizing further. You're reducing waste and optimizing resources, and there's a lot more automation built in things as well. So there is a lot here, and we're just getting started in many ways from an IoT perspective. So as you think about the technology choices, think about three pegs of the stool here. They all need to be somewhat balanced to make sure that people can actually sit on the stool. First, I would say is really the customer experience innovation. So what experience are we actually trying to deliver to the customer? Is it faster time to market for them? Is it proactively making sure that things never go down? Is the service aspect? Is it the experience with the data that you're providing? We need to understand what that is and what the opportunity for you from that experience is to ensure that that's taken into consideration. The other part is the operating and business model optimization. One of the challenges that we've seen is that it's relatively easy to bring the product to market, but it's difficult to see and understand ahead of time what the changes to the organization will be because of that. So for instance, if you just took a product out that used to be sold through a channel and now you're making it available directly from a B2B perspective, then people will have questions directly to you. Are you able to take and source those questions? Are you able to respond to them in real time? So customer service, call centers, all of those things need to be considered. Are you able to take payments differently? For instance, for things, are you able to build up a subscription model, for instance, right? So those are questions that have to be thought through ahead of time before you kind of just engineer the product and get it to market. And the third aspect is obviously the product and service innovation. When we talk about product and service innovation, we're saying that there is hardware engineering required, but there's also software and embedded software within that hardware that really makes a huge difference in what kinds of solutions and services that you bring to market. And obviously the technology innovation, whether it's the cloud, whether it's the DevOps part, whether it's edge analytics, it's machine learning, all of those are also playing a role. So these three things have to be considered. And as a technologist, my suggestion to you is, have those conversations with your business ahead of time around operating model, around the business model optimization, around customer experience, so that you're able to take those things in consideration as you decide what is the right cloud platform and technology stack that you want to really bet your next 5-year strategy or next 2 or 3 year strategy on. So with that, let's talk about what some of the challenges are. I highlighted them a little bit, but we'll quickly go through them here. There is aspect of an organizational strategy that needs to be considered first. There is going to obviously be hardware and connectivity considerations. Is the industrial design, is the mechanical electrical design, is that how are we going to scale the manufacturing of it? How are we going to buy or build our own sort of components that make our product connected? In this data and analytics part of it, from our experience in the past, a lot of the industrial manufacturing organizations are not software engineering behemoths, right? It's a cultural shift for a lot of companies to start thinking of themselves as software companies as well. So how do we think about DevOps and data and access to enterprise systems, and a lot of those things have to be thought through. And then obviously there's applications that need to enable for various audiences, for the customer, for the field, for the partner, for the channel, for internal call service agents. So how are you going to enable all the different parties to ensure that the experience that a customer has transcends across just themselves and throughout your organization. And then obviously there's operations that have to be thought through as well. So reason for saying that is that you as a technologist should have these conversations with your business and be ready to provide a platform through which you can talk about how technology will enable aspects of all of this. So let's get started. We're talking about how to think about the various, what we're calling the smart services solution components from a technology standpoint. And this is really our framework and our reference architecture that we'll double click on throughout the presentation. First of all, let's start from the left. It's really the device fundamentally. And for the device, there's engineering required. So one of the things that I've seen successful companies do is really bring the engineering teams with the software teams and with the strategy teams collectively together as a virtual team as this process begins, because the input from the strategy to the software technology and the hardware engineering really needs to be understood in holistically, not just from a roadmap perspective of what can be done when, but also from a cost perspective, so that your organization understands what it's really going to cost to do something. So the device is really the core. And we say the device, it really means, it depends on how you're engineering your product. Is it a black box that will get engineered and during assembly just connected to some aspects of your product? Is it we're really embedding the mechanical the electricals within the within the product itself? Who's going to do that? I mean, there's aspects of that, right? On another note, you may have a strategy where you are creating a product, you're taking a standalone existing product in the market and retrofitting that to provide connected capabilities. And in that case, what does it look like? Another question then is, are we having our connected product, our connected machine, to either talk directly to the cloud, or is it going to be through some kind of a gateway? If that's the case, what does my gateway strategy look like as well? And what kind of intelligence am I going to be able to do on the device or on the gateway before data is sent to the cloud, right? So those are considerations there. You move to the network, then the question is, how will this product actually be connected to the cloud? And there's various choices here, and obviously it depends on your scenario and what what kind of a machine and what kind of environment your machines are in, and all of that will play a role. But obviously there are some easy ones out there, like cellular connectivity, or whether it's Wi-Fi, or is it LoRa, or is it Sigfox, as a Bluetooth BLE. There's various options there. We need to really understand why a certain option would be better for you. Moving towards the right, you have the Cloud IoT Platform, which really fundamentally provides the ability for millions of devices to connect, have bidirectional communication, authentication, and then be able to pass the data on to various data and application services, which are on the right-hand side. So fundamentally, the data is what is the key here. So you have cloud data services that everything from storing the data, managing the data, to analyzing the data, to predicting, to operationalizing AI. All of those aspects are here. And then the last aspect, which is really important fundamentally in the end, is the experience. How is all of this being perceived by the people that you're delivering value to, whether it might be your consumers, whether it's a customer, whether it's a factory floor technician? How are you enabling that experience for them? Because that's where the rubber meets the road. So here you have options around mobile technology. You have augmented reality, obviously the web, visualization, data visualization, business process automation. Those are aspects that you need to consider here. So those are the fundamental areas of our solution, IoT solution components. But underneath all of that is a security consideration. So securing the device at the edge, securing the network, securing the cloud IoT platform, securing the data, securing the experiences. There it goes across the board. And then there is underneath that another layer around management. So how is this device going to be managed? How is it going to be provisioned? How is it going to be deprovisioned? How are you going to manage the access from the network perspective? How are we managing the cloud and cloud services? So those are considerations that we have to make. And underneath that are automation capabilities. So a lot of the cloud platforms provide automation of your services. How can we bring new services up and running quickly? So this idea of infrastructure as a service, infrastructure as code, how do we make that happen and use those capabilities? So if you want to create a new environment in a new region, our business decides that we are opening up a new office in Europe, how can we spin up the right set of service and get up and running as quickly as possible using automation techniques? So the goal today is to drill into each one of these a little bit more in detail and then compare the various cloud platforms. So let's start with, as we start drilling into it, you'll see the colors here. We're really defining 3 different subsystems within your solution component, right? One is what we call the IoT subsystem. So the blues are really, that includes your device, it includes the network, and it includes the cloud IoT platform. Then you have, as you should think about it, as a data and analytics subsystem. So all the services in the cloud and capabilities of the cloud that enable you to harness the power of this data, right? That's the cloud data and analytics subsystem. And the final is the experience subsystem, which is all about what kinds of services are available to actually deliver amazing experiences from this data. So let's peel the onion out and let's look at the IoT subsystem for a second and talk about what are the capabilities. So we talked about the high-level device, network, and cloud IoT platform. What does it really mean? So if we look at the device, fundamentally, any device that is either powering your product, or it is an edge device, or it is a gateway device, fundamentally has the following components, right? It has a microcontroller system on a chip. On top of that, you have some kind of sensors that are connected to that, whatever kinds of sensors are enabling the services that you will deliver, right, from your product, whether it's vibration, whether it's temperature, any of those things. On top of that, you have some kind of a real-time operating system. Now, real-time operating systems are really built for low power, long use, secure authentication with cloud platforms, compartmentalizing capabilities on the device, so that it's easier to manage and administer the device. So the OSs are very specialized here, and we'll talk about how various cloud IoT platforms are providing custom OSs to help you with that. On top of the OS, you typically will have some kind of a IoT platform software development kit, some kind of an SDK. The goal of the SDK is to be able to connect to the cloud IoT platform, number one, securely, and then pass messages back and forth in a secure manner. And most of the cloud platform providers provide that capability. So things like, what cloud platform should I connect to when I wake up? How do I know when to send messages? How should I know when the handshake and receiving a message is? How do I enable over-the-air updates? All of those things are here. And then finally, on the device, you may have some kind of an application code that allows a device to do things or perform certain functions that may be there. So think about, when you're making a decision on a device, you have to consider every aspect of and obviously your engineering team will be very closely participating in this journey with you. But you can see the handshake between engineering and software here, because there is embedded software here. Why depending on what cloud platform you select, there are implications of that on the device itself. Now, I talk about edge device here. We talk about application code specifically for edge device. Edge devices may have more capability to actually process data, to actually perform some machine learning and do some alerting, things like that, right on the device itself. So again, depending on what kind of device and what you wanted to do, you may have to consider the right set of engineering options from a microcontroller, from a system on chip kind of design that will support that. A good part is that there's a lot of learnings out there already around that, right? So I will talk about some of the options that companies like Microsoft and Amazon and IBM have done in that, working with the microcontroller manufacturers that make the whole interconnected aspect of this work much better. You have a gateway device. Again, sometimes a gateway device is just a proxy for the device to be able to connect to the cloud. Sometimes a gateway device may be the proxy and actually analyze the data before it's sent to the cloud. So depending again on your situation, the environment your product is in will dictate what this gateway device may do. In the end, the gateway device, or the device itself directly connects to the cloud. And that's where the method of communication is very important. Now, moving to the right, from there on, that's when, assuming that you have a device or through the gateway, it's connected to the cloud, and it knows which cloud IoT platform to connect to. And the reason why it knows that is because the IoT Platform SDK that you have on your device is enabling that that knowledge for the device, what to do when. In this case, you've got the cloud IoT platform. Obviously, that's in the cloud, whether it's with Microsoft or Amazon or IBM or Google or whoever. There's a bunch of them today. So let's talk about what are the core capabilities of the IoT platform. So fundamentally, the IoT platform is all about enabling, first of all, secure authentication of the device, ingestion of the data, provisioning of the device, also something called device twins, managing a device twin. So being able to say, hey, this is what the virtual properties of the device are. So any application that wants to actually interact with the device could almost, could interact with its twin, its digital twin, and not have to work directly with the device itself. This capability is very important, not just from a security perspective, but also in a disconnected or relatively sparsely connected devices as well. You still want systems to actually continue working, and device twins are a great way of doing that. And one of the other main important things that an IoT platform does is provides the command and control. So what does that mean? It means that we are, we are able to actually provide commands back to the device in a secure manner, which tell the device to do things, perform an action, or maybe even physically or remotely connect and control the device as well. So those are sort of the main characteristics of the flow between the device, the connectivity, and the IoT platform. There are some ancillary services that you should be aware of. One of them, which sometimes gets overlooked actually, is device management. If you have 10, 15, 20 products, it's one thing. If you have 1 million products out in the market, or even 1,000 products out in the market, then how do you manage them? How do you know what's up, what's running, what's not sending data, and why? Is it because something's wrong with the device, something's wrong with the network? And that's where another aspect is very important, called service management. Service management is from a network perspective that provides you real-time insights into, is the network actually seeing the device? Is it not seeing the device? It can help us understand when was the last time it was connected, when did it successfully connect, can I still ping it? Those kinds of things the service management dashboard will tell you, and the device management will actually be able to give you more insights into what's happening on the device, maybe do over-the-air updates and things like that directly. There's also this concept of device discovery, where your device is able to be discovered by other devices, and they can actually begin some kind of a handshake and exchange of data and things like that. So this is an up-and-coming area still, but I feel like that is something that you should start looking into, as more and more business models in the future will depend on autonomous capabilities. So that's our IoT cloud, our IoT subsystem. Obviously, there's security on top. So how are we making sure the device is secure on the field? It's securely connecting to the network, is securely connecting to the IoT platform, is securely receiving commands, is executing code on the device securely. We need to be able to kind of worry about those things. And good part is that a lot of cloud IoT platform providers are thinking about that stuff as well. So that's the IoT subsystem. If we unpack or double click in the data and analytics subsystem, you really are looking at three main things. You're looking at data ingestion. First of all, when we think data ingestion, it's very easy to think that the the only data we're receiving is the data from the sensors that the device is sending. And yes, that is obviously a very critical component of the ingestion of that. But also there is something called device health. You want to be able to also ingest, how is a device looking like at any given moment in time, and that gives you more insights into, how the device is working, what the health of the device is. It goes beyond just being able to ping. And then there's finally service data. So you want to be able to say, is this how much, what kind of bandwidth is this device using, especially if you are and your company are charging your clients for the connectivity. So you're saying to the clients, hey, I'm going to give you a package of 1 meg per month. You need to know how much bandwidth is your device already using, and you need to be able to bill for that accordingly, and you need that kind of an infrastructure to support that. So service data, when we say service data, we mean really the connectivity service data is important as well to ingest. So anytime you are talking to your network provider for your internet, for your cloud, for your connectivity, for your device, you've got to make sure that you have the ability from an API perspective to be able to consume that per device, so that you can provide a holistic view to your clients when it's necessary. And not to just your clients, but also your service member, your call center folks, your field service folks, so they know what's going on as well. Then obviously the main aspect here is stream processing. The data is coming in stream. It's not a batch thing. You need to be able to actually analyze the data and capitalize on the data as it's coming in. So things like being able to correlate the data to certain, to a particular device, perform, expert knowledge, and applying those rules. Perhaps, you may have a system that is built first using rules. If this, then that. But over time, you may want to, replace that or augment that with machine learning and AI, so that the system is able to provide much more deeper insights than just the rules that you may have. You may also need to transform data. You may need to to split data streams into two and send one here and send one there. You want the system to be able to handle those kinds of things. And then finally, you want to be able to store this data from a scale perspective. Obviously, this is quote unquote the big data part of it. So data storage, being able to use that data store to then analyze the data, to report the data, to build dashboards off of, to actually enable machine learning to happen. Being able to store other organization data like customer data, for instance, and then ambient data. What was going on? What was the temperature outside? What was the weather quality outside, et cetera. Those factors that may influence the quality of the service that you may be providing from your product perspective. And then finally, you have the experience system. This is where everything comes together. So here, from a experience perspective, again, you have audiences. You may have the customer, you may have the channel, you may have the field, you may have the regulators, you may have your call center. So there's various people that need access to these insights and what they do with these insights. And you need to be able to understand what are the use cases there, so that you're designing the system in a manner that delivers the value to those individual folks. So the way we think about it is really, this is where the differentiation happens as well, by the way. So your product, in order to differentiate itself from others, needs to deliver superior experience. So what does experience mean? It means self-service. It means convenience. It means insights. It means actionable information, not just information, actionable information. It means automation, process automation. It means all of those things. So really think about making sure that you're not taking the easy way out by saying, hey, here's a portal, here's all the data. That's not the goal here. It's to really empower self-service, convenience, all those kinds of things. So emerging obviously is augmented reality. We're doing a lot of work in that space, from remote assist and being able to actually visualize complex environments in the 3D model, but also provide access to experts in the field that may not be physically in person to be able to diagnose and triage issues as they happen. Device commands, being able to send back from an experience is important. Provisioning devices or updating devices, or data visualization and alerts, intelligent alerts, business process automation, all of those are capabilities that you have to think about from, is my platform, that I'm going to select going to enable me to do that. Maybe you start off with a portal, and that's okay, but then you need to extend that to more richer use cases. And then finally, the automation is all of this that we talked about from a cloud perspective, the IoT platform, data, storage, experience, all that can be automated and developed. So let's talk about next about what are the cloud platforms doing. So let's look at the cloud platforms here. So what I'm going to do is focus on 3 cloud platforms, because they are all 3 of them are in a certain sense, different stages of their own maturity. The industry as a whole is maturing at a pace. Then the individual platforms are maturing at a pace, and we need to make sure we understand where how and where their own strategies are going, so that you are making the right investments. So I will talk about that. And these are not the only 3, by the way, right? There's many there as well. Google obviously has a space here, and there's more. GE has one as well with Predict. So there's many here. It's hard to compare all of them in one webinar, but I've taken the 3 that are relatively more common and talk to you about them. So let's start with IoT security. So, and we'll compare each 3 of them with what kinds of capabilities they have. Obviously, from an IoT security consideration standpoint, remember, we talked about it. It transcends the device. It transcends network, cloud, data, and the experiences. And in reality, the security isn't just a solution that you can get from Microsoft or just Azure, or it's a framework through how you build a device, through how how the engineering is performed, to how you will update it, how will you secure the data on, etc. So there's all kinds of layers of security here. But I want to focus on what are the 3 platforms enabling for you and giving you, so that you have a deeper sense of how far they extend. So let's start with the Microsoft here. Microsoft probably has the richest security story, and the reason for that is because last year Microsoft released something called Azure Sphere, and Azure Sphere is a set of 3 things that come together. First, they've designed the reference architecture for a secured microcontroller. And they've worked with partners like ARM, like MediaTek, like Seed, who are manufacturing that MCU. Now, why is that important? It is important because that MCU is, the reference architecture, has on top of it a secure Linux-based OS that Microsoft has written, and also a cloud security service that provides a security service, monitoring and managing the device's security on the device itself. So those 3 things that you would have to worry about individually, Microsoft has done that with the partnerships from engineering firms together. And that's really powerful, because the cloud security service provides a guaranteed experience. The OS, it provides compartmentalization, it provides containerization, and all of these learnings are from Microsoft's building devices, and bringing those devices to market at a high scale. So that's one of their solutions. Obviously, they have something called Azure Security Center for IoT, and the Azure Security Center for IoT, it is looking for and eliminating threats with giving you step-by-step guidance on how to do that, and configuration suggestions across the services that you may be using within Azure to support your IoT product. And then they have something called Azure Sentinel, which really is a threat detection and a response, AI-based response service that is predicting threats and giving you those insights. So when you layer those 3 things in there, it's covering a decent amount of ground as far as what the level of security layers that you can apply. Now, Amazon has something called AWS IoT Device Defender service. It's a fully managed service within Amazon, and it is constantly auditing, your device twin configurations, the various aspects of your IoT, services that you're using within AWS, and providing, very similar to Sentinel, AI-based, security best practices and threat and providing those threat information to you. And IBM has something called IBM Watson. So IBM's platform is called IBM Watson IoT. They have something called IBM Watson IoT Advanced Security. And it's really, I think, a starting point for IBM to start getting into more of the threat detection and response and suggested configuration. But they do have that service, and is starting to kind of provide good insights into security best practices used within the IBM IoT Cloud. Clearly, Microsoft has a much stronger position in this case from an IoT security perspective. When you go to the operating system, I believe Microsoft again has a stronger solution here. And I'll tell you why is that. Because Amazon, IBM, first of all, IBM doesn't have any kind of a OS that they supply. They rely on multiple real-time operating systems that are existing and available, and you can obviously put the IBM IoT SDK on that OS that can then provide you connectivity with the IBM Cloud. Amazon acquired the free RTOS operating system. It was an open source, and it's still an open source operating system that Amazon is continuing, and it's a pretty popular real-time operating system. Powers billions of devices here already. So it has very deep integrations with the Azure IoT Core, which is the IoT Core service in the cloud, and also with IoT Greengrass. IoT Greengrass is Amazon's edge solution for enabling edge computing on the device. So Amazon's strategy is free RTOS. Obviously, you can take the Amazon IoT SDK and put it on, just like IBM, on any operating system. There's no limitation in that perspective. This is just the OS that Amazon's providing. Microsoft, on the other hand, looks at it from a market maturity perspective and looks at what kinds of capabilities certain devices would need. So obviously, Windows 10 IoT Core, Windows as an operating system for IoT devices, is available. It's an optimized version to run on smaller devices. It runs both on ARM and x86, x64 devices, and supports the Windows IoT, Azure IoT SDK that can then talk to the Azure IoT Cloud. We also talked about the Azure Sphere. That is a Linux-based OS, and it comes with a secure crowd service, and knows how to connect to not just to, by the way, to Azure IoT, but can also talk to Amazon IoT if you'd like it to. So the Azure Sphere service is almost disconnected necessarily from having to absolutely for you to use the Azure IoT. All right, so that's one thing. And then Microsoft just this week announced the acquisition of Express Logic that makes one of the most popular RTOS called ThreadX, which really is built and geared towards very small footprint devices that have to run with very small memory, very secure, and is on billions of devices already, right? So Microsoft has covered the spectrum, if you may, much broadly than I think the others have. But again, I think the free RTOS is a very popular operating system as well. Now let's come to the device SDK. So remember, we have security, we have the OS, and we need the SDK that will tell the device which IoT instance on the cloud that it needs to connect to, talk to, and then actually manage the secure authentication connectivity. So the device SDK is a really important one. And both Microsoft and Amazon have good SDKs. They both support various languages. So your SDK, you could implement the SDK on C, C#, Java, Python, Node.js on the device. Same thing with Amazon's AWS. Both provide support for standard messaging formats like MQTT, AMQP, HTTP, for instance. I think both are extremely strong in what they do and what they're built to do. So either one is fine. Obviously, the Azure, if you select Azure as your platform, then you would use the Azure IoT Device SDK. If you use, if you select AWS as a platform, then you would use the AWS IoT Device SDK. Then you come to the Cloud IoT Platform itself. So this is where the core IoT service in the cloud is. If you remember back to our diagram, and this is where we're now the device is now connecting to the core IoT service. This is where the device, the IoT core service is going to securely allow the device to connect to the cloud platform, ingest and allow millions of them to do at the same time, high scale, manage the bidirectional communication, with the devices, support provisioning, support device twin capability, command and control capability. So Microsoft solution is Azure IoT Hub, and it is an extremely scalable service in the cloud. And Amazon's is called AWS IoT Core. Again, extremely scalable, and provides things like not just device twins, but also intermittent connectivity or broken, disconnected devices and what happens when they connect. Very rich in functionality in all of those cases. IBM has its Watson IoT Platform service. Again, supports a lot of the similar capabilities, but I would say that Amazon and Microsoft have been working on this for about 3 or 4 years longer than IBM has. So certainly a lot more richer capabilities there for them. When we come to device management, that's where things get a little different. So device management, often overlooked, is a very important aspect of your IoT strategy. And it's about how are you going to manage all these devices? How do you understand what's going on with any given device at any given moment in time? How will you update them when need be? And it's not a consumer-facing sort of experience. It's more of a backend. But even then, you need to really deliver the customer experience, you need to understand what's going on. So Azure doesn't really have a very good solution. It has something called Azure IoT Central. It provides, I would say, basic device management capabilities. Unlike Amazon, that has something called AWS IoT Device Management Service, where it provides a lot more richer capabilities, where you can register connected devices, you can manage permissions on those devices, you can organize them in groups, you can monitor and troubleshoot them remotely, you can query the data, query the state, you can send over their updates. It's a very nicely done service. IBM has some extensions that you can do on top of their IoT platform that enable device management, but again, something you would have to do a little bit more custom. Both Amazon, I would say Amazon is definitely leading in this area. The next thing to discuss is IoT at the edge. Now, IoT at the edge is one critical element, because one of the things obviously is that you're not necessarily going to send millions of data points and events all the time to the cloud. You don't necessarily have to do that. Maybe you want to send, the key events, or maybe group them, or maybe convert them to insights and send those insights to the cloud. And you need platform to be able to support that. So both, actually, all three of them have capabilities in that case. IBM is a newer; it's still in preview actually, but again, all three of them have that. I would say that Azure's IoT Edge, so one of the aspects of an edge service you want is to be able to take, you want to be able to have a cloud platform that can take all the services that you have coded in the cloud to manage the stream of data coming in and be able to push all of that logic down to the device. You want that ability because you don't want to be developing one for the edge and then one for the cloud platform. You want the same code to work on both on the edge device as well as the cloud. And that's where I think Microsoft's done a really good job of making the services that you would use in the cloud and making them available on IoT Edge, so that the same code you write is available and allows you to actually, from a time to market, manageability, supportability to actually do that. But also the services are very rich. Everything from stream analytics to machine learning, all of that can be done, on the device using, IoT Edge. Amazon's AWS IoT Greengrass Again, very powerful as well. You can run predictions using machine learning models that you've built in the cloud and deploy them on the device. You can keep the data in sync. You can remotely connect to the device as well. So lots of great capabilities. Both Azure and AWS are doing a great job in that space. When you go to the data and analytics subsystem, what I've done on the left-hand side is giving you what are the capabilities that you need to be aware of. So things like stream processing, data lake storage, meaning you want to be able to store data in a manner that it's coming in, regardless of the format. So, you may want to bring in other information, perhaps beyond just the IoT device data. Big data management, analytics, NoSQL database so that you're able to power richer experiences, perhaps a cloud data warehouse that, as data grows and then, provides much more traditional data warehousing capabilities, and then obviously machine learning. Now, all of them have capabilities here. So Microsoft Azure, lots of capability. Amazon AWS, lots of capability. IBM has some gaps here and there, but generally has a good machine learning capability with Watson. Amazon has definitely created a significant amount of focus on its data capabilities. So Amazon's AWS S3, which really is powering now as a data lake store, AWS IoT Analytics, specifically built for IoT. This is very good, capability there. AWS Redshift is a very strong contender for cloud data warehouse built on built many years ago now, actually. And then machine learning capabilities in Amazon are extremely strong. So lots of cognitive services like vision, speech, etc. And we know from Alexa and all those, right? There's really a lot of powerful capabilities there. Imagine powering your experiences now, right? How would they use all that data? AWS SageMaker as well. So lots of capability there. Azure has done a great job in big data management recently with its partnership with Databricks that brings Apache Spark to Azure. And that's a very, very strong solution from a big data perspective. It has lots of the capabilities in things like Azure time series insights that are very specific and very useful in analyzing IoT data from a stream perspective. Cosmos DB, which is a NoSQL database and is compatible with MongoDB, for instance, as well. Azure SQL Data Warehouse, again, a solution that's been around on the on-premises side, is also now available in the cloud as a service. And then you have machine learning like Azure ML, various types of Azure cognitive services as well, almost as rich as, I would say, as Amazon in this case. We talk about experience development. That's where Microsoft really has a leg up. and you think about visualization. So, Power BI, Microsoft's data visualization platform, has full embeddable capabilities. You can embed the visualizations in your product. Your analysts can build those visualizations. You can embed them in portals and service frameworks. Quick Insights from Amazon, still relatively new as well. Mobile development, Microsoft acquired Xamarin a few years ago now, which provides you cross-platform development. So you build once for both iOS and Android. It has mobile apps as a service that lets you deploy mobile apps, as well. From the web perspective, Azure Maps, again, for integrating sort of, map capability, geo capabilities in your solutions. Web apps, Azure SignalR for real-time, updating of experiences. So imagine, you're looking at a portal, numbers are changing in real time. That's where SignalR is very useful. API management, if you're exposing APIs to other ecosystem partners or other partners so that they can build experiences on top of your system or your solution, that's possible. Notification Hub, which provides first-class notifications for iOS and Android and mobile applications. Augmented reality, very, very strong. Obviously, they have HoloLens, spatial anchors, remote rendering, lots of capabilities, integration with systems like Dynamics, if you're using, especially if you're a Dynamics customer. And then your development environment. So Visual Studio, they've got the Kubernetes service, the container instances, So as you evolve into your DevOps, you're able to leverage these technologies as well. And then from a business process automation, has something called Azure Logic Apps. This is the beyond. This is kind of where the BizTalk on the on-premises side, which allows you to fundamentally automate business processes using the data that's coming in. So much richer than both Amazon and IBM. Though Amazon has lots of capabilities on a development side, with DevOps, with the code build, code commit, code deploy, code pipeline capability, services. You have container services for Amazon to build modern microservices based architecture based applications. You have obviously you have mobile services, web services as well. So again, it is Microsoft has done a lot of work, and traditionally it's been Microsoft's sort of pedigree in from a development standpoint and experience standpoint. So that shows here in the cloud. So just kind of putting it together here, when you think about Azure's IoT technologies and solutions, you'll see there's the device support here, Windows 10, there's Azure IoT SDK. They've also got the Azure Sphere here. There are other services around IoT, the IoT Hub, which is a core service, IoT Edge, time series I talked about, Azure Sphere, Azure Maps. All of those are very specific to IoT. Data analytics, I talked about these. The visualization and integration, those are also talked about here. So this is sort of a one view of all of that coming together, and very complete. And if you look at Amazon's as well, this is AWS IoT. You've got the free RTOS. You've got Greengrass on the device, which is the edge computing stuff. You've got the core IoT service in the cloud. You've got device management, the security device defender, the IoT Things Graph, connect devices and other web services. You've got the data services, IoT analytics, IoT site-wise, IoT events, all powerful data analytics, stream analytics side, and then obviously all the richer experiences the development side as well. So lots of capability on both sides. The challenge obviously is how do you think about them? I think when do you pick what? And I kind of did a little rating here. Said, okay, for the various things that we talked about, IoT subsystem, data and analytics, experience, etc. How would we rate them? And from an IoT subsystem, primarily because of the security capabilities, the various OSs, and how Microsoft's expanding and ensuring that the spectrum of devices that they support with OS support and security services, has I would say a leg up on Amazon at this time. From a data and analytics side, we have the Amazon definitely is a bit higher on that spectrum. Azure has lots of rich capabilities. IBM definitely a strong contender there as well. When you think about the experience, we talked about it. Azure definitely takes the cake there. It just has a lot of powerful experience development capabilities. Security, Azure up ahead slightly from Amazon, primarily because of the Azure Sphere security architecture and security service. Automation, infrastructure as code, a lot of capabilities in both Amazon and Azure. Hardware ecosystem, both missed it clearly there, but both Amazon and Azure have worked extensively with engineering partners and hardware, component providers like MCU manufacturers, like system on chip manufacturers, like sensor manufacturers, to ensure their support for the platform. So things like being if you're microcontroller manufacturer, if you're a sensor manufacturer, you can basically be Azure IoT certified or AWS certified and bring solutions to market. And that does take a lot of work to create these kinds of ecosystem and capabilities. And from an edge IoT perspective, both Amazon and Azure are very strong. So the question then begs is, when would you use what platform? And I would say that Microsoft Azure is best for sort of B2B applications, for you providing if you're building a platform, a solution for your customer who is also a business. Obviously in industrial machine case, that makes a lot of sense. Then access to enterprise data and user access is important. So being able to leverage your existing investments. If you're already a Microsoft shop in Active Directory, in in the infrastructure, that you already have Microsoft on premises, then extending that to the cloud is a lot easier and better with the Microsoft Azure IoT space. When you are really thinking about making experience a differentiator for you, Microsoft has a better story. So better mobile, stronger augmented reality, stronger web development, business process automation, all of that is much stronger with Microsoft. And if security is something that you're really, really hard on, you should look at Microsoft's spectrum of solutions. From an AWS perspective, I think we're launching a B2C connected product with all its cognitive services and lots of powerful capabilities there. You could build a pretty rich B2C connected product and bring that to market, a very fast time to market there. If your product is strong on data, use of data and cognitive, then I would suggest consider AWS as the right platform. So lots to consider there, but again, I'll go back to saying that there is a lot of other considerations as we started the webinar. Before you kind of get to this point, from your operating model, from your strategy, from your business model considerations, from customer experience strategy, all of those should play also as important as a role in determining what kind of platform is best for you. So quick view of who Productive Edge is. We're a digital business consulting technology solutions company, headquartered in Chicago, offices in Boston and other countries around the world. We've been around since 2008. We focus heavily on what we call digital transformation services, IoT-based products and services, and bringing them to market is one of our core specialties, along with intelligent automation, data and analytics, mobile as well. With IoT at Productive Edge, we focus on experiences. That's our goal, is to ensure that you deliver and bring extremely differentiated products to market. So it's how do we combine the best of the IoT platform with the engineering, with artificial intelligence, and things like mixed reality, and how will that power the right type of experience that differentiates your product and delivers the business goals that you may have as your business. For example, we've done a lot of work in augmented reality. We have something called remote assist. We've built a accelerator for that allows experts to remotely connect through a person physically at the site, through a HoloLens type virtual reality device, and is able to actually see IoT data coming from the device, and be able to suggest and react to issues and suggest and provide insights into how best to solve problems to someone that may not understand how best to do that in the field. So again, we're pushing the envelope in those areas, and our service offerings are quite broad, specifically in the IoT space. We help in organization strategy and helping you craft what that strategy should be. What is the roadmap for your experience that you should think about? What are the opportunities? What's the ROI? What is the real cost of engineering? Really doing that. And we've partnered very closely with multiple hardware engineering firms that work with us from a software perspective, and really brings the risk factor down for you, because we know how to work with each other, and we've done this in the past. So we can bring the engineering, both hardware and software, together very, very, very strongly. And then obviously our experiences in the cloud IoT platforms and data and analytics and AI, and building those experiences. So with that, I want to thank you for spending the time with me. I'm happy to take questions now, and I'm also working on a longer, much thorough comparison of the IoT platforms. You saw a snippet of that today. I will be including Google IoT in that as well. So if you'd like that copy of that when it releases in the summer, feel free to email me. My email is rretiwala@productiveedge.com. With that, I want to thank you for taking the time, and always happy to answer any questions now, or feel free to ping me, and I'll be happy to see where you are and how we can help you potentially in your journey. Thank you very much.